This is the lesson 1.2, solving multi-step equations. To solve a multi-step equation, we first need to simplify both sides of the equal sign, or each side of the equation. Then we use our inverse operations to get the variable all alone on one side of the equal sign. What are the inverse operations? Do you remember? So we know addition and subtraction are opposites of one another, and multiplication and division are opposites of one another. So we call those the inverse operations. Now let's look at some examples. So remember, a multi or a two-step equation is the same thing as a one-step equation, other than the fact that we're literally just adding one step. So on your screen, you should see the equation 2.5x minus 13 equals 2. Right now, I'm noticing that we have a minus 13 attached to a 2.5x. To get that negative 13 or minus 13 to the other side, we do the opposite of subtraction, which is addition. So to undo that subtraction, we add 13 to both sides. That's going to cancel out the 13s on the left, and we're left with 2.5x equals 2 plus 13, which is 15. That takes care of the first step. However, x is still not by itself on one side of the equal sign. It's being multiplied by 2.5x. To undo that, we divide both sides by 2.5. That cancels out the 2.5s on the left-hand side, and we're left with 15 divided by 2.5, which is 6. Now that x is all alone on one side of the equal sign, we have completed the problem, and the solution is 6. Here's another problem. We have negative 12 equals 9x minus 6x plus 15. Again, this is very similar to the one before. The only difference I'm noticing is that we have two groups of x's on the right-hand side. Since we have a 9x minus a 6x, we can just combine those terms since they are alike. And 9x minus 6x is 3x. So all we did there was combined. Our goal is to still get x all alone on one side of the equal sign. So to do that, we need to move that plus 15. Well, the opposite of adding is subtracting, so let's subtract 15 to both sides. That's going to cancel our 15 minus 15 on the right, and we're left with negative 27 equals 3x. Finally, we need to get that 3 that's being multiplied by x canceled out by dividing by 3 on both sides. When we divide by 3 on both sides, we can see that we get negative 9 equals x for our solution. So to summarize, you are still using your inverse operations to solve these equations. However, the only difference is between the first lesson and the second lesson is that you have one more step.